Hello, welcome to another video of Code Snippet, and this is going to be a one-shot video on Docker. If you are working in IT industry in 2026, then learning Docker is very important. Because you might already be aware that a lot of organizations are making use of Docker to share their applications. A lot of libraries and softwares are available on Docker Hub now, and developers are making use of it and making their life easy. Mostly all microservices are being containerized and being deployed on cloud environment. If you are doing open source contributions, you might have seen a lot of Docker images flowing through. So it is very important to be aware and have working knowledge on Docker in today's market condition. So by the end of this video, you will have a working knowledge on Docker and will be able to work on Docker right away. So let's get started without wasting any time. This is going to be another fun video. So sit back, relax and enjoy the show. Alright, so let's quickly go through the agenda of this particular video. So Docker basically, and this is going to be a one-shot video on Docker. It is kind of a complete course on Docker. So let's see what we are going to go through. So first we will see why Docker exists. We will first understand the problem. Why do we need Docker in the first place, right? We will first understand the problem. After that, we will see what exactly is Docker. After that, we will look into the architecture of the Docker. We will understand basic terminologies like container, images, daemon, etc. After that, we will see how we can install Docker on our machines. After that, we will containerize a Spring Boot application. We will actually write a Spring Boot application. While doing this, there are many things that will come into picture, different commands we are going to go through. We will see what exactly is Docker file. We will see what is port mapping. We will see how we can do environment config. After that, we will see what exactly is Docker Compose. Very important stuff. After that, we will look into Docker volumes and networking at the end. So this is basically the overall agenda, overall high level agenda, in which we are going to look into many things in this particular video and very important stuff. So that is basically the agenda of this particular video. You will find different timestamps on this particular video. So what you can do, you can switch between the topics, but I will recommend you go ahead and watch this video in sequence to understand everything. So let's get started with the first one and see why Docker exists, and we'll first try to understand the problem. Alright, so let's go to this canvas over here, and let's say you have this particular developer. Let's say this is basically the developer inside our team. The name is basically Bob. Now Bob have one machine over here with him, right? Bob have one machine. It is basically a Windows machine, Windows laptop or Windows machine he is running basically. After that, let's say he is working on Java application. So let's say he have a Java version, let's say Java 25, right? After that, let's say he is working on MySQL. He have some version of MySQL. Let's say MySQL 8 or so. After that, he also have a Mongo running, let's say Mongo 6, right? This is basically the tech stack this guy working on, right? Our friend Bob is working on this particular tech stack now. Now, after doing all this, after installing all this guy developed an application, a Spring Boot application, let's say, right? Spring Boot application this guy has developed. Now, you might have heard a lot of people saying that this particular functionality works on my machine. This particular application works on my machine. Why it is failing inside production, I don't know. You might have heard a lot of people saying that. Why that happens? Now, let's say this particular guy writes this particular application. Everything is working just fine. Now, the time comes that our friend delegates this particular application and asks our friend QA to test it. Now, let's say Alice, the QA, is now going to test this particular application. What Alice will do now, Alice will take this application and try to deploy it on a QA environment. Now this is basically a QA environment, right? Now let's say, what is the configuration of this particular environment, right? Let's try to duplicate this. And now let's say this particular QA machine is working on Linux, right? After that, this particular QA have Java 17 installed and MySQL version is 7, let's say, and Mongo version is, let's say, 5. Whenever Alice is going to deploy this particular application to this QA environment, what will happen? Because of this OS and this particular version mismatch, definitely there will be some failures on this particular application on QA environment. So Alice will say, dude, Bob, this is not working on QA machine. But Bob will say, my friend Alice, this is working on my local machine. What should I do? Right? This is basically the problem we are facing. Now, this is basically with another environment. Let's say there is some other developer joins this particular team, right? Now we had Bob developer. Now let's say there is some other developer saying, let's say Charlie. Now Charlie joined this particular team. Charlie got a machine, right? Now what Charlie have? Charlie have a MacBook. Now Charlie is working on Java 21. Charlie is working on MySQL 7. and he has some latest Mongo version, let's say 9. I'm not sure what is the latest version or what is the version of Mongo. I'm just giving some example over here, right? After that, what Bob will do, Bob will push this particular application on GitHub repository, ask Charlie to pull it and run it. Now our friend Charlie pulled it and trying to run this particular application. But now this particular application is failing because there is this particular different configuration, different environment, different dependency versions and stuff, right? Now Charlie is going to Bob that, dude, it is not working on my local. What should I do? Bob says, dude, it works on my local. Let's get into the call and let's try to solve your problem. Now they will go into the call. Bob will say, dude, you are working on MacBook in the first place. I don't know what to do. After that, he will look into the version. Now he will say, I'm running on 25. You upgrade your version to 25. You're using MySQL 7, go on MySQL 8. So this guy upgrades. You're using Mongo 9, make use of 6. Now this guy upgrades and downgrades everything. And now he tries to run this application. Now it works just fine, right? So it is basically extra efforts that Charlie had to do in order to make this application works on his local. After that, this particular application is failing over here. So this particular application should be compatible with this particular version. So we'll either have to increase this particular Java version, MySQL version, Mongo version to latest one or compatible with this particular application, or we'll have to make this application or make application changes to support Java 17.7 and 5 Mongo as well. So those are the problems that our developers are facing over here. And these are basically the problems with your environment mismatch, right? Because you have different environment, you have version mismatches, you have deployment problems, you have dependency problems. So all those problems are basically there, and all our developers, QAs are facing this problem in real time because they have different versions and dependencies and different OS that are running basically. Now traditionally, in order to solve this problem, what people will do, people will write kind of a heavy documentation, installation steps, readme files and blah, right? But that will not help, right? That is not a best solution to this problem because people will have to put on efforts in doing all that, right? So what is the best solution over here? What exactly is the best solution? So Docker comes up with best solution to this problem and solves this problem effectively. So that is when Docker comes into picture. Now how Docker solves this problem, we will see in a bit. So let's go back over here. So now we understand the problem, right? How Docker will solve the problem. First, let's see what exactly is Docker. Right? So now let's see what exactly is the Docker over here. So what is Docker? Docker is a tool, right? So it is basically a tool, nothing else, right? It is basically a simple tool that allows you to package your application and its entire environment into a single unit. Now let's see how. Now let's say all these folks are making use of Docker. Now what Docker will do, all these things Docker will bundle into a single unit. So let's say there is this particular unit. Now what Docker will do, Docker will put application code over here in this particular unit. After that, it will put the Java runtime environment, let's say Java versions. After that, whatever libraries are needed by this particular application, that can be added over here. After that, all the OS packages can be added. All the config files can be added over here, right? So whatever this particular Java application or any other application, let's say Node application needs to run will be added in this particular unit. And this particular unit will define all the things that are needed by that particular application in order to run. Now, this is basically kind of a template. Now to understand this, let's take a simple example of, let's say, architecture. Let's say this is a building architecture, right? Let's say there is a builder who is building a different buildings, right? Now the size and shape of the building will be same, and what he will do, he will just prepare the architecture. Right? It is kind of a template of a building architecture, and by using this architecture, a builder can now build different buildings. For example, let's say there is this particular building. By using this architecture, he can build this particular building, right? What he can do, he can build another building by using this particular same architecture, right? He can build n number of buildings by using this particular similar architecture. There is no limit to it basically. And all these particular buildings will be same in nature because they are coming from same architecture. We give the similar example for classes and object inside Java. So if you are familiar with Java, Java will have something called as class, which is a template of your object. And by using one class, you can create different objects, right? By using one class, you can create different objects. For example, let's say there is a building class, and by using that building class, you can create a different buildings, right? Similarly, as this particular builder have this architecture, Docker have this particular template. And by using this template, Docker can run this particular application at different instances. There are different instances. Let's say here this particular same app is running, here this particular same app is running, and here this particular same app can run basically. Now, this particular template that we just saw is called as a Docker image. And this particular Docker image can run in different containers. So this particular running instance is basically a Docker container. We can run different containers by using same image. So this is basically the template which knows what exactly to run. What is the application code? What exactly is the runtime environment? What are the dependency versions? What are the environment configuration? Everything is bundled over here. This Docker image can be run in different containers on any environment, on any machine. Now, what our friend Bob can do, instead of sharing this application, what Bob can do, Bob can create a simple image of this particular application and share this image with our friend, this particular Charlie. What Charlie will do, Charlie will just run this image inside a container, right? Inside a container, Docker container on his machine, and all these things won't come into picture. Just that there will be his MacBook, and on that MacBook, this guy has installed Docker, and Docker will just run this image inside a container, right? Simple stuff basically. And he will share the same image with our friend QA, that is Alice, and Alice will run this particular Docker image on this particular Linux environment. And if this particular application is working in this particular image, if this particular image is working fine inside a container, then this image will work anywhere on any machine irrespective of the OS or what are the different versions installed on that particular machine, because this image will not use this particular versions which are installed on this particular Windows. It will use the versions that are bundled inside that particular image, right? All these particular versions which are needed to run this particular application code. So that is how your Docker image and Docker container stuff comes into picture. So Docker container is just an instance which runs your Docker image, right? Simple stuff basically related to this particular example, and you will know it. Now let's go back over here. So that is basically the Docker for you. We have seen what exactly is Docker, why Docker exists, and we have seen what exactly is the Docker. And we have had a glance on what is Docker image and Docker container. We will look into it in detail when we look into the architecture part of it, right? All right, so let's jump to what exactly is Docker architecture. So let's go through the Docker architecture. This is going to be fun now, right? So let's go back over here. And let's say this is basically the architecture, right? This architecture is not given by Docker. It is just that I have created it in order to understand what exactly is going on behind the scene. Now, let's say there is this user, right? Our friend Bob basically. Now, if you remember this, now Bob is making use of image, right? Bob is making use of now Docker. Now, Bob needs something to interact with Docker, right? How Bob is going to play around Docker? What Bob needs to do? Bob first needs to install Docker on its machine. How we can install Docker on our machine? We will see that in a bit. But when you install Docker on your machine, you will get a command line interface, right? You will get a command line interface, kind of a terminal, where you can go ahead and type commands in order to interact with Docker. So we will get a Docker CLI, and our friend Bob can go and type commands on this particular Docker CLI. Or we will also have another option, kind of a UI option, which is called as a Docker desktop. We will go ahead and install it in a bit, but we also have this particular option available when it comes to our local machine, right? But this particular option is not available, this desktop option, when we actually go ahead and make use of a AWS environment or any other environment where we actually go ahead and deploy our application. So I recommend not to use this particular desktop, rather than go ahead and make use of Docker CLI. But when we install it, everything basically that you see on the screen will come as a bundle inside your machine, right? So you can go ahead and make use of it in order to visualize, but I will recommend make use of Docker CLI, because you will not get Docker desktop when it comes to AWS or other environments, cloud environments, where you go ahead and install your images. That is basically your Docker CLI. Now, our friend is making use of these tools to interact with Docker. Now, once you do, Docker needs something in order to perform operations, right? That is when Docker daemon comes into picture. All the commands that this particular user is throwing at Docker, who is executing them? Our friend Docker daemon is executing them, right? This is basically the brain, and this is basically the core of Docker. And if you do not have Docker daemon running inside your local or any other environment, your queries will not just work. Now, Docker daemon have multiple responsibilities. Docker daemon have multiple responsibilities of executing these commands, like depending on different commands. Like if I'm saying Docker build, it will just go ahead and build images. If I'm saying run container, it will just create a container and run it. It will manage networks, it will manage volumes, it will do everything basically that we are asking it to do by using Docker CLI. So it is basically that Docker CLI will communicate with Docker daemon through kind of a API. So it is a REST API communication, and it will perform those actions, right? Now Docker daemon will be basically running at a background of your application, right? Simple stuff. And both of them together, Docker CLI and Docker daemon, is called as Docker engine. That means once these two are running on your machine, we say that Docker engine is basically running on your machine, right? It's kind of a terminology stuff, nothing big over here. After that, let's go back over here. Now, let's say Bob make use of all this and create an image, right, on his machine. Now, how this guy Bob can share this image with our friend Charlie, right? How Bob can share with Charlie, or how Bob can share with Alice over here. He needs something to store this image where Charlie can seamlessly pull it from that particular storage environment, right? So for this purpose, there is something called as Docker registry and Docker hub, where people can go ahead and push their image and make it available publicly to accessed by anyone. Docker registry or Docker hub comes into picture, and whenever this particular user throws command that Docker pull something, if this particular Docker daemon finds that there is this particular image is not available over here in the local machine, what it will do? It will go ahead and connect to this particular Docker registry or Docker hub and pull the image on the machine on which it is running. After that, it will try to run it, right? Simple stuff basically. How cool is that, right? How simple stuff. Very simple basically, right? Now, parallelly as we are learning, let's try to implement or let's try to install this particular Docker engine on our local. What I will do, I will just go ahead and try to search for Docker over here. And here I will go ahead and click on this link which says Docker desktop. And what I will do, I will just go ahead and download it from here, right? So let's say download for Mac, download for Mac Intel chip, download for Windows or Linux. Based on your environment, just go ahead and download and install it. Once I click on this, it will just start downloading this particular stuff for me, right? It is kind of a DMG file for me. Based on your environment, it will be a different files. Now I already have downloaded it basically in my local and installed it. So you just need to install. And once you install Docker desktop, all these things like Docker CLI, Docker daemon, and Docker desktop all together will be installed on your machine. So you don't really have to do much over there, right? Once you do that, you can just go into any terminal. Basically, let me just open a terminal, right? Let me just zoom it a bit so that it's clearly visible over here. There we go. I hope it is visible now. Now, if I try to say Docker, let me try to hit any Docker command. Let's say Docker PS. Then you will see that I'm getting an error saying cannot connect to Docker daemon at this particular path. Is the Docker daemon running, right? Now what I did, this is basically Docker CLI for me. It is basically any terminal on which Docker is installed. You can just go ahead and hit this particular command to check if Docker is installed, basically like Docker -- version over here, and it will show you that Docker is basically installed, right? Now it is saying that Docker is not running, right? In order to run Docker daemon, this particular Docker daemon is basically not running on my local. So in order to run this, what I need to do, I need to start my Docker desktop. What I will do, I will just type Docker and I will just start it over here. So Docker desktop should be coming in. So let me see. There we go. Docker desktop is basically started over here, right? So this is how Docker desktop basically looks. Let me just zoom it a bit so that things are clearly visible. Now this guy is basically, now I just opened it, right? Once I open this, it should start Docker daemon as well. Now if I go ahead and say Docker PS again, then we will see that we are not getting any error now because our friend Docker desktop is basically running. Simple stuff. Now here if you see, let me just go through all the things over here. I will just give you a quick tour. If I click over here, you will see that different containers. These are basically older containers that I ran, but they are not running anymore now. They are just sitting there. After that, here you will see the different images that I have on my local. After that, different volumes, different builds, and there are different things basically. So once we run any of the container, you can just go ahead and see it over here, or you can see it by using command line interface over here, or this particular terminal over here, right? Simple stuff. Now let's go back over here. So now once you install Docker desktop, you will get this particular things over here, and our friend Docker will be running on your local. Let's also try to explore this Docker registry. So what I will do, I will just set Docker registry over here. I will just try to search for it, and I will go to this particular link over here which says Docker Hub. There we go. So this is basically our Docker Hub. Now you can just go ahead and sign up over here in order to push our images. Or what I will do, let's try to search Java over here. Let's see what we have. If you see over here, we have Java over here. Java is basically running. We have Alpine Java. We have different images over here, right? Simple stuff basically. After that, if I try to search for, let's say, Spring Boot, let's see what we have based on Spring Boot. So these are basically different images. For example, if I go into this particular Spring Boot, which is coming from Linux Foundation, how we can run this, right? Here you will see that we are directly getting this particular option to run it inside a Docker. Or if I click over here, you will see that there is this particular command which says Docker pull, and this is basically the name of our this particular image. Now what we will do, let's try to copy that and paste over here, right? So Docker pull this particular image, and let's try to hit enter. Now if you see, it is pulling the image from this particular Docker Hub. Now download is complete. Now the image is basically downloaded over here, right? Now we have downloaded the image, right? Now if I go into, let's say, Docker -help, it will just give us all the commands that are basically available to Docker, right? So if I go back over here, then you will see that we have different commands basically. So we have Docker run, which will create and run an image. We have Docker run command. After that, we have Docker exec, or execute a command inside a running container. Then we have ps, which is basically list containers. We have build to build new container. We have pull, push, pull we have just seen, right? Push to upload image. We have images to list image. We have login, logout, search, version info, a lot of basically commands basically, right? Now here if we see, let me try to hit this particular command. Let's say Docker images now. Then you will see what are different images. So this is basically the image that we just pulled, right? After that, it will be available over here as well. So here if you see, this is basically the image, right? After that, let's try to pull another one basically. So what I will do, let's say there is this particular image. Let's say there is this Nginx, right? So let's try to install Nginx basically. What we'll do, we'll just pull this particular image. Let me just copy this particular. Let's try to copy this particular command for Docker pull, or instead of directly saying Docker pull, we'll just say Docker directly. We can directly run it, and I will just say Nginx, right? And let's try to hit this particular command. So now what it is doing, it is saying that unable to find this particular image locally, right? Because we are not doing Docker pull, we are saying Docker run directly. Now here you will see that it has started pulling this particular Nginx from our Docker Hub. It has downloaded and it has started this particular image, right? So here you will see that the image is basically running, and image is basically running inside a container. Now if I go over here, then you will see that this particular container is running. The name is Nifty Saha. It gives kind of funny random names over here to this particular container. This is basically container ID, and this is basically Nginx image running. Now if I say Control C over here, then that particular container will just stop. So here if you see, the container should have been stopped. So here if you see, it is not running basically. So it will just go ahead and exit and stop when we say Control C over here. So in order to stop that, what we can do, we can just say Docker. We can just say Docker run, and we can just give -d flag, which is basically detach mode. And now if I run it, then it will just start in backend, right? Now here if you see, if I go back over here and let's try to scroll it, it has created another container for me, right? So now same image is basically running at different containers. I can just go ahead and start this particular container as well, and that also will just work fine, right? Now there are two containers running. Now in order to list what exactly is running, we can just say docker ps. And here you will see that we have two container runnings, which are basically running the same images, right? But the container ID is now different. Now if I go back over here, now the same image is running different containers. So there is this nginx image, which is running app1, app2, which is running different containers, container1 and container2, right? Same thing is running in different containers. And what we did, we just pulled it and run it, right? And now in order to stop this particular container, what we can do, we can just copy this container ID. We can just say docker stop, and we can just paste this particular container over here, and that particular container will be stopped. Now if I say docker ps, only one container is basically running, right? And now I will just again stop this particular container as well, because we don't really want it running, right? So I will just say docker stop, and I will just give this particular ID, right? And now what I will do, if I say docker ps, now we will see nothing, right? There is basically nothing over here. Let me just clear this once. But now let's say I want to see that what all containers are basically present, right? So I will just say docker ps -a. That will show me all the containers even if they are not running, right? So let me just try to minimize this stuff. Now here you will see all the containers are basically exited over here, right? All the containers are basically exited. Now when I say docker run, it spins up new container. But if I want to start the existing container, I can just go ahead and do that from here. So I'll just say docker start container ID, and that particular container will just start. If you see over here, it is up now, right? I will just go ahead and stop it again. I don't really want it. So I'll just say docker ps, not docker ps, basically I will just say docker stop and paste it over here, and that will again go ahead and stop. Now you will see nothing is basically running. That is basically how your image and container basically works, right? Not only your different libraries, like we have run nginx, right? Simply you can run different environments as well. For example, if I go over here, let me just try to search for, let's say, Ubuntu. Now there is this Ubuntu, right? Let me just go ahead and try to run this Ubuntu on my local over here. Now what I will do, I'll just say docker pull. It is trying to pull the latest Ubuntu from our docker hub now, and it is pulled basically. Now if I say docker images, then you will see that we have this Ubuntu images basically present. Let me clear again, and now let's try to run this particular docker run, and let's try to run it in interactive mode so that we can communicate with it, right? So it will just give us a console. Then we actually go ahead and make use of this IT flag, and I will just say Ubuntu. So now it has started. Now if I can just go ahead and hit all the Ubuntu specific commands, right? So you will see that all the stuff that we have over here in the Linux is basically present over here. So simply I just ran this particular Ubuntu image, and this particular Ubuntu is running on my local with zero effort. How much effort is to run Ubuntu on a Windows machine? You will need to do partition and stuff, right? You can just go ahead and make use of Docker, and that's it, right? Simple stuff, isn't it? Now if I go back over here, you will see that this particular friendly something image is running, and which is running Ubuntu for us. And here what I can do, I can just say, I can just go ahead and create some files over here. If I do ls now, you will see that this particular file is created and stuff, right? And I can just go ahead and come out of it saying exit, right? And I can just say docker ps now to see this particular container, and you will see that it is not running anymore because we exited out of it, right? So it stopped basically. So that is how you can run another environment as well on your this particular Docker, right? All right, so now until now we have seen the Docker architecture. After that we have seen the Docker installation. After that, let's go ahead and let's try to containerize a Spring Boot application. What I will do now, let me go back over here. So this is basically a simple Spring Boot project over here. So in this project we don't really have much over here. So if I go inside it, we have a couple of controllers. This controller will just return some stuff for us. After that, we have a name controller over here. There are a couple of things that we are doing in the name controller. So here we have a post mapping API, which will just add a name inside a given file. So we have this file path over here. So on this file path, so if I go inside this particular application.yaml, then you will see that we have this particular file path. So in this particular file, this particular name will just be added. After that, we have a get API and a delete API as well. And here, if you see, a name.txt will be created. Now, if I quickly run this particular application, let me just quickly run this and try to hit this particular API. So let's say if I hit the get API, we are not getting anything. Let's try to put this particular name over here. So this is basically a post API which says names, and I'm just adding a name over here. If I send it, you will see the name will be saved. If I do get now, you will see that the name will be added over here. And there is this particular delete API as well. If I hit this, then you will see the name will be removed. And if I add it again, you will see this particular names file will be updated basically, right? Simple stuff. So that is basically the job of this particular application. Now, this particular application YAML exposes this particular port. That means this application is running on 8080, which is basically a default port. This is the name of our application. Simple stuff, right? Now, this particular application, when I run it, it is running on my local. This is running on my MacBook, right? If you see, this Spring Boot application is basically running on my MacBook. Now, let me stop it. Now, what we need to do, we need to run this particular application on Docker. So first of all, what we need to do, we need to create a Docker image. So how we can create the image of this particular application, right? So this entire application we have, how we can create an image. For this purpose, what we need a Docker file, right? Now, what exactly is the Docker file? A Docker file is a text file that contains step-by-step instructions to create a Docker image, right? So it is just a simple file which will have instructions to create an image. So let's try to create a new Docker file. So let's say this is basically an empty file that we have created. It's a simple Docker file. Now what do we need to add over here, right? So it is kind of a recipe to build your image, right? So what are minimum things that are needed in order to build a Docker file, right? So let me just highlight the minimum things. So first you need is a base image, because every image have a parent image to it. We don't really start from scratch. We extend some existing image and we build on top of that, right? So we start with so this is basically a Java project. So we start with the image. So let's say we start with the image which already have Java installed. So I will just say from Java, or you can also give OpenJDK over here, right? We can give OpenJDK as well. OpenJDK image. You can do colon and specify the exact version you want as well, or you can just go with the latest one, right? Does not really matter. So I'll just say from OpenJDK, which is basically my base image. After that, second thing I need over here is I need to specify the working directory once this particular image is basically running. So inside that particular image, what working directory I want. So that is something I need to highlight. Right? How I can do that? I can just say work dir and I will just say app over here. So this is basically my working directory. So step 2 completed, right? After that, third basic thing that we need is basically copy files, right? What we need to do, whatever project files that you have, you need to copy it inside this particular directory. While building this image, all these files can be copied. So if I say ... all the files that are present over here will be copied. But this is now a Java project, right? So if I go inside it, you will see that in the target folder, if I go ahead and say maven install over here, I will just go ahead and say maven install. So what maven install will do, maven install will just create a jar file. So jar file will contain everything related to this project, right? Executable. So what we can do, we can just copy this jar file instead of copying everything, right? What I will do, I will just say from target, copy my jar, right? So this particular jar, I want to copy from this particular target, right? Let me zoom it as well. So that is basically third thing that I wanted to do. After that, fourth thing, right? Fourth thing is what I want to do after I copy the files. I want to expose a port on which my application will be running inside my container. So I will just say expose and I will just specify the container, let's say container port, let's say 8080, simple stuff. So expose 8080 means this particular container on which this particular image is going to be deployed listens on this particular 8080 port. Listens on this particular 8080 port. That means if we send something to 8080 port, this particular container will be listening to that and will respond to that particular request. After that, at the end, what I need to do, I need to give the startup command. So now this is the last thing that we need. We need a startup command. We need to tell how this particular application is going to be started, right? So we need to specify the entry point. So we'll just say entry point, and here we will say, how do we start our Java application? We just say Java jar, and we will just give our jar, right? We will just give our jar name like app.jar or something like that, right? Whatever is the name. Now when we copy this particular jar file, we will just save it as app.jar inside a container, right? So that we can just give this particular command over here. Now how we can give over here? We can just say Java, and after that we can just say -jar, and at the end what we can do, we can just say the name of our friend, that is app.jar. That is how we give this particular entry point. What it will do, it will just at the end will run this command, right? So that is basically our Docker file. So we have successfully created our first Docker file. So first we added the parent image. After that we created a working directory. We copied our jar file to working directory. We expose this port and we add an entry point. These are the minimal things that you need inside a Docker file. You can do whatever you want over here, but these are the minimal things that you need to do, right? Now, since the Docker file is generated, what we want to do? We want to create an image from this Docker file. What we can do, we can just go ahead and run the command now, Docker, and in order to create image, the command is basically Docker build. So I can just say Docker build dot. Dot means the directory of your Docker file. Dot means where is the directory of your Docker file. Now my Docker file is in a parent directory, that's why I'm giving dot over here. Now this will do, but this will just create an image with some random name. So in order to give my specific name, I can just say -t, that means tag this particular image. And what I can do, I can just give the name as Docker -demo, and I can just say version like version 1.0, right? This is basically my first image. Now let's hit enter. Let's see what happens. Now you will see that it is building our Docker image, and it failed. It failed saying that it says OpenJDK latest is not found. So OpenJDK latest probably is not there. Looks like OpenJDK they have removed. So what we can do, let's go to Docker Hub and let's try to find. Let's probably go inside this Eclipse Tamarind, and what I will do, I'll just go ahead and copy. And I will just go ahead and copy this particular name. That is basically enough for us. So what I will do, I'll just replace this with this particular image. So this is again a separate image for our OpenJDK, right? So this is basically image for OpenJDK. So now let's try to run it again, right? So let's say Docker build now. Now it is basically building, and it will first pull this particular image from Docker Hub, and on top of that it will just try to build. Now the build is successful. Now what we will do, let's say Docker images, right? So let me just say Docker images over here, and do we have our image? You will see that Docker image tag 1.0 is basically present over here, right? Simple stuff basically. So now our image is basically built. Now let's try to run our image, right? Now how we can run that? We can just say Docker run. We can give the name of our image. Let's say Docker demo. Let me copy it and paste it over here. Now let's try to run it. Let me just hit enter. I need to specify version as well. So let me just say 1.0 because it's trying to run this Docker demo latest, which is not available. So let me just give the version as well. Now it should start our application. Now here, if you see, our Spring Boot application is just coming up inside a Docker environment, right? So it is basically started. Now if I go back over here, let's go to the Docker desktop. Let me go back to Docker desktop over here. Then you will see that our sweet bale is started, which is running our image, right? And now let's try to hit our APIs. Let me try to hit this get API. Now you will say, now here you will see that could not send request. So it's not able to send the request. Now what exactly is happening? Now let me go back over here and let's go to canvas over here. Now here we have our MacBook, right? So this is basically our MacBook, right? MacBook, or let's say Windows machine, whatever we use. Let's say we have this MacBook over here. Now inside my MacBook, what I have Docker here. Let's say we have a Docker, and in this Docker a container is running. So this is basically my container, which is basically running my Spring Boot application. So container is running my application, right? And now I'm trying to hit this particular endpoint from my Postman, right? So now inside my MacBook I have my Postman running, which sends the request to port 8080. Now when the Postman is sending the request to 8080, now the 8080 port belongs to my MacBook over here. This 8080 port belongs to my MacBook over here, and there is nothing running on this 8080 port, right? Because this port belongs to my MacBook. But there is some application running inside containers 8080 port, right? Inside containers 8080 port, there is some application running. But what is happening when my Postman sends to 8080 port, my local MacBook's 8080 is running nothing, but my containers 8080 is running something. What I need to do? I need to do mapping between these two, right? I need to do port mapping between these two, so that whenever my MacBook's Postman sends request to 8080, it goes to 8080 of your container application. So that mapping I need to do. And now how that mapping can be done? Let me go back over here. I will go to our friend IntelliJ, and let me say Control C over here, which will stop our container. So now if I say Docker PS, you will see that nothing is basically running. Now what I will do, I will just say Docker run, and I will give, or let's run the previous command, this command basically, Docker run Docker demo 1. But now before that, what we need to do, we need to map our friend 8080 inside MacBook to our friend 8080 inside a container. What I will do, I will just say 8080 inside my MacBook is mapping to 8080 inside my container. So that is what we called as a container mapping. Now if I hit this particular endpoint, now you will see that the application is started again. And now let's try to hit this endpoint. Now if you see, we are getting this particular response. Now if I send something, let's say, let's try to add some names over here, and let's try to get that particular name. Now this particular name is basically added over here, right? Simple stuff. And now if you see, this particular application is just running, and if I say Control C over here, then it will just stop again. In order to run it, let's say in order to run it in detached mode, I can just say -D, so it will just run in background, right? It will just run in background. And now let's say I want to log into that container, right? What I can do, I can just say Docker exec, that means execute, right? -it means give me an interactive terminal in order to communicate to that particular Docker container. After that, what do I need? I need a name of that particular Docker machine. So what I will do, or let's do Docker first so that we have all the details handy. So this is basically our container. So let me just copy the container ID. And now what I will do, I'll just say Docker exec, that means execute -it means interactive mode, and we'll just give the container ID. And what we'll say, we'll just say that give me some bash so that I can execute some commands on this particular container. Now if I hit it, we are getting a bash terminal. Now if I say ls, we will see that we have this app.jar that we have copied. If I say JPS, then you will see all the Java processes that are running over here. So that is how you can log in inside a container as well. Docker exec is basically execute command, and you can directly log in inside your container, interactive container, by using bash command, right? And I can just say exit, and it will just exit the container. Now if you see, our Docker is basically still running, our container is basically still running. Now let's try to go back inside our container. So let's just go back over here, and let's try to add some name over here. Now if you see, we don't really have anything since we restarted our container. And now let me add Chetan, and if I go back over here, you will see that this particular name is added. Now here if I say ls, you will see that the name.txt is basically created over here. And now if I try to look into what exactly is there inside this particular names.txt, then you will see our friend Chetan is basically present over there, right? So this particular name is there. If I try to add one more, let's try to add someone else probably. Let's try to add Pushpa. So let's add Pushpa over here. And if I send it, you will see that there are a couple of names now. And if I do cat names again, you will see that there are a couple of names, right? Simple stuff basically. So that is how you can run this particular container, and that is how you can map the port, right? So let me go back over here. So here we have seen what exactly is Docker file. We have seen the port mapping basically, right? Let's see what exactly is environment config. Now here we are running this application on 8080, right? What I will do, I will just go back over here and let's try to parameterize this, right? So what I will do, I will just say dollar, and here what I will do, I will say server underscore port colon 8080, right? That means you can override this particular server port by using this variable. If this is not found, then make use of this default 8080. Now let me, what I can do, I can just stop this particular container. Let me exit from here. And what I will do, I will just stop this particular container. I will just say docker ps, and let me say docker, and let me say docker stop, and I will just give this particular container ID. Let me copy that and paste it over here. Our friend just stopped, right? So there is no container running basically now. So now what I will do, I will start the container again. Now what I will do, I will just say docker, I will just say run, and let's go back to our older command basically in order to run our friend, right? So now this is basically our older command, docker run -d-p 80808080, right? Now what we will do, we will give one flag that is -e, that means environment variable. And here what we will do, we will just give server port, and we will give server port equals to 9090, let's say this time. And now when it comes to port mapping, now the port inside container is changed. Now it is changed to 9090, right? So what we need to do, we need to change this particular port mapping to 9090. So 8080 at my local to 9090 in the container. Now let's try to bring this up, right? Now if I say docker ps, then our new container has been created and it is running. Now let's try to hit this particular get request. Now let me send it. Now one thing you might have observed is that all our names have been vanished because this container created is new. This is not an existing container, isn't it? And all the data that we had was in the last container. We'll come back to it later, right? Just remember that we are having this particular problem. Now what we will do, now if you see here, you will see that there is this particular container mapping that the local host 8080 is being mapped to 9090 port inside our container. So left side is basically your host and right side is basically your container port, right? Now what I will do, let's say docker stop, right? Let me stop this guy. Let me just stop this guy. I will just say docker stop, right? And let's try to start it again. Now this time I will say 9090 at the left side as well, and let me run it. And now if I say docker ps, a new container has been started, and let me try to hit this. It won't work basically because we need to change the port over here. So let me just try to change it, and it is just working just fine, right? Simple stuff basically. So that's how your port mapping and the environment mapping just work, right? Now if I do docker ps -a, then you will see that we have a lot of containers basically created. None of them are basically running, right? So many containers we have created, and in order to remove all of them, you can just say docker container, you can just say docker container prune, and it will just remove all the containers basically. You just need to say yes over here, and all the containers are basically removed. Now if I say docker ps-a, then you will see that all the containers which were not running are basically deleted, and only the container which is running is basically present over here. This also I will just say docker stop and stop this particular container as well. And if you see docker prune again, then that particular container will also be removed, right? Simple stuff. And now docker ps-a will return nothing, and same thing will be visible over here. Now here you will see there are basically no containers in the Docker desktop. Simple stuff basically. Alright, so now we have seen environment config as well, and we have containerized our Spring Boot application, right? Now, before moving to Docker Compose, let's see what exactly are Docker volumes. Now let me go back over here. If I say Docker ps-a, then you will see that we don't really have any container now. Now what we will do, let's try to spin up a container with our image, right? So let me just hit this particular command. So now if I say Docker ps, then you will see our container is basically running. Now if I try to get the name, it will be empty basically. If I try to add it, let me just add Pushpa over here and let me get it. You will see that we are getting this particular name over here, right? But now what I will do, I will just say Docker stop, and I will just stop this container. And what I will do, I will just run our image again. Now if I go back over here and try to get the data, then you will see that we don't really have the data. What is the reason? Because here if you see, if I say Docker ps-a, then you will see when we rerun our application, a new container was started, this one, right? And this was the older one. Now this container have the data that we were looking for, but this container do not really have the data. Because the new container is generated, we don't really have this data, right? And now if I can go ahead and add it again, now if I add it, you will see that I have this particular data over here. Let me probably add my name as well, and let's send it. Then you will see that we have this data. Now what I will do, I will just say Docker stop, and I will stop this running instance now. I will just go ahead and stop this running instance. And now if I say Docker ps, both the instances are stopped basically. And now what I will do, I will start the same instance again, the same instance that was running. Instead of creating a new one, instead of running my image again, I'm just starting the same container again. So let me just hit this command and the container is started. Now let me try to send this. Now you will see that we are getting the data, right? So the data is present inside the container, but when we run our image, a new container will be spin up and that container will not have that particular data. So the data is specific to container basically, right? What I will do, I will just stop this particular container again. So in order to visualize, if you see over here, when a container starts, when we run our image, it runs a container, right? When we run another image, it runs another container. When we run image third time, it will create another container, right? It will create a container 3. The image is basically the same image, which is running different containers, and each container have its own copy of our names. This guy will have its own copy of names. This guy will have its own copy of names. This guy will have its own copy of names. What do we want to do? We want to make it data common for all the containers, no matter how many containers are being created. I want to make this data common, right? Make this data common, let's say names, so that all the containers can go ahead and connect to it, right? This is a simple use case that we want to do now. So all the containers should connect to this guy. And now this can be achieved by using volumes, right? Docker volumes. This can be easily achieved by using Docker volumes. And now let's see how we can do it, right? So what I will do, first I will do Docker container, so that all the existing containers will be deleted. Now if I say Docker ps-a, you will see that we don't really have much over here. After that, now what I will do, I will try to run our container again, right? This particular Docker image I will try to run again, right? And what I will do over here, I will add another flag, let's say -v volume. -v is basically volume. I will give some name to my volume. I will say name -volume, let's say, and I will specify what is the directory I want to include in this particular volume, the directory inside a container, right? So our working directory is basically app, and our data is being stored at app. So I will just mention this particular directory that I want to create a volume from this particular directory for our containers. And that's it. Let me just hit enter. So our friend is created now. So I will just say Docker ps now, and you will see that this particular container is basically created. Now you will see that there will be nothing basically. And now let's try to add a couple of names. Let's say Chetan, let's say Pushpa, let's say Shrivalli. 3 names are basically added. Now if I try to send this, you will see that these 3 names are basically present. And now what I will do, I will just stop this container and let's try to spin up a new one. What I will do, I'll say docker stop, and let me try to spin up the new container with the same command again. So if I do docker ps-a, now you will see that this particular new container is started and the older container is ended basically. But we created this data by using older container. Now let's try to send it. Now you will see the data basically persist, because the data is basically persist inside the volume now instead of being persisted in the container. So the data is in the volume. And in order to visualize your volumes, we can just say docker volume and we'll say ls, right? So here you will see that we have this particular volume, that is name volume, created over here. Name volume is basically created for us, right? And we can just go ahead and inspect that as well. So we can just say docker volume, can hit the inspect command and say name hyphen volume, and you will see that we have all the details related to this particular volume, and all the details basically are available over here. If you want to remove the volume, let's say if you want to remove the volume, you can just say docker, you can just say docker volume rm and just give the name of the docker volume, that is name hyphen vol over here, and you will see the volume is in use. It says the volume is in use because our friend container is basically using that particular volume. Now what we need to do, we need to stop this particular container first before removing that particular volume. So I'll just say docker stop and give the container ID. Now if I try to remove this volume, it will just be removed. It says it's still in use by the container. So what we need to do, we need to remove the containers. So what I will do, I will just say docker container prune, then it should prune the data. Yes, and it will remove everything. Now let's try to remove the volume and the volume will be basically removed. And now if we try to list the volumes over here, then you will see that our volume is basically not present. Simple stuff, right? So that is basically how you can make use of volumes. Simple stuff basically. To have a common data between the containers, you can make use of volumes. Also, one more thing I want to highlight over here, since we are looking into this, is so what we can do, instead of having the local volumes over here, instead of having these docker volumes over here, we can also store the data inside the file inside our host. That means the file inside our this particular machine. So let's say this is basically the file, right? Let me just remove all the data over here. What we need to do, let's try to copy the file path over here. So what I will do, I will just try to copy the path and I will just go ahead and copy this particular path over here. So what I want to do, instead of storing the names inside the file in the container, I want to make use of this file in my host to store all the data. So how we can do that? Let me just go back to that particular command over here. What we can do now, instead of giving this particular volume, what we can do, we can give the full path of our file. So the path that we have copied, let me just paste it, right? And I want to copy the path inside app/names.txt. So whatever data is there in the names.txt, I want to put it inside names.txt in my host, in my file which is running at my MacBook. Now let's try to run it. And once I do that, you will see our container is basically started, right? Now let's go back over here and let's try to get some names. You'll see that we don't really have much over here. Let's try to add this particular name over here, and now let's try to get the name. You will see that Shrivalli is basically added. And here if you see, our file in our MacBook is basically being updated, right? Now if I try to get it again, it will just give us the name. Let's try to add one more basically. So what I will do, I will just say Chetan and let's try to send it. You will see it will be updated runtime because our Docker is connected to this particular file and updating this stuff at runtime, right? Let's try to add Pushpa as well. It should also get added over here at runtime. And let's try to delete Chetan now. Let's see what happens. Let me just change the port over here to 9090 and send it. You will see the Chetan is basically removed. How cool is that, right? This concept is basically called as bind mount. So you can use the local files as a volume inside your Docker, right? So that is something I wanted to highlight, right? Simple stuff basically. Now what I will do, I'll just say docker ps, and let me just stop this particular container, not needed anymore. So what I will do, I'll just say docker stop, and let me just stop this. All right, so now if I go back over here, then we have seen Docker volumes as well. Now let's proceed and let's see what exactly is Docker Compose. Now if I go back over here, and if you see over here, in order to run our image, how long this particular command is becoming. In order to run our image, we need to do all this. We need to do all this flag -d -v blah blah blah, lot of stuff basically, right? Do you think we will do this every day, right? We cannot just go ahead and do this every day in order to, run our Docker image. We cannot just give all these flags and all these ports and all these files and stuff, right? We don't really do that. In order to solve this problem, something called as Docker Compose comes into picture. So what Docker Compose will do, Docker Compose allows us to define and run multi-container Docker applications using a YAML file. That means all this configuration, all these flags and stuff will go into a YAML file. So what we can do, we can just create a YAML file over here. So I will just say new, and I will just say file over here, and I will just say docker -compose YML, that is a YAML file. So now we have this Docker Compose file, right? Now what do we want to do? We want to put everything that we have over here in this particular Docker Compose file. First of all, what we can do, we can just give the version of our Docker file, let's say 1.0, right? Simple stuff. First version. After that, what we can do, we can add our services. So let's say I want to add my app over here. Now which image my app is going to use? So we will add an image name. So image name, what I will do, I'll just copy this image name from here and put it over here. That is basically my image. After that, what I can do, I can add ports as well. So what port mapping we have? We have 9090. So 9090:9090, right? Simple stuff. After that, what do we need? What do we have over here? We have environment, right? So we have -e. So what we will do, we will just say environment, and inside environment, what do we have? We have server underscore port, and what value we have given? 9090 we have given, right? And that's it. Server port 9090, simple stuff. After that, what do we have? Let's say we have a volume, right? We have volume. What was our volume? Let's say names -volume. And what did we give? We give app as our directory from which we want to pull it, right? And since we have volume at the root, we need to highlight that volume as well, that what are the volumes that are present in this particular Docker. So we'll just give the name of our volume over here. So we'll just say name.volume, name-volume. Basically, this is basically the name that we need to define, so that it will just create that volume for us, right? That is basically our Docker file. Now what we will do, how we can run this particular Docker file, how we can run this particular Docker compose.yaml. You will see the options to run over here as well, but there is a command as well. So we can just say docker compose up, right? Docker compose up. If I can spell compose correctly, we'll say docker compose up. And guess what? There is an error. It says environment must be a mapping. What did we do? This should be colon, not our equals to basically. Now let's try to run this again. Volumes must be a mapping volumes as well. There should be a colon over here, so that it will just go ahead and create this particular volume. And now let's try to bring it up. Now you'll see that it is started creating our friend. So here, if you see, it has created the network, the volume, and the container for us, right? And our application just started over here. Now if I try to send something, or if I try to get something, you will see that there is nothing. If I try to save the name and try to get it, we are just getting the name, right? Simple stuff. Now if I say Control-C over here, then it will just stop the container as well. And if you want to do it in detached mode, we need to add -d over here, and it will just start the container. And now in this case, it will start the same container basically. It has created by using this particular Docker Compose file. And if you are making use of IntelliJ, you will find everything over here. So this is basically our Docker Compose file. If I open this, then this is basically our application. So you will see the apps here as well. And all other containers that are present will be available over here. For example, this one is basically there. And if I go inside volumes, you will see that this particular volume is basically created for us. After that, all the images are basically present over here. So you can add a Docker extension inside your IntelliJ and you will be able to see all this, right? So that is how basically you can make use of Docker Compose, right? And now you can just say Docker Compose down in order to stop your application, and it will just be removed. So if you see over here now, so Docker container is basically stopped, right? Simple stuff. But the volume will still be there, because when you spin the container up again, the same volume should be attached. So if I do this now and try to pull the names again, you will see that we have same data, because now it is making use of volumes to pull the data for us. So that is how we can make use of Docker Compose. So let me just stop this. That is how Docker Compose file comes into picture. So never be confused between your Docker file and Docker Compose, because Docker file will come into picture when you want to create the image. And in order to give multiple options like this while running your image, you can make use of Docker Compose, so that you don't really have to write that long command, right? So to avoid that, you can make use of this guy. Simple stuff, right? So that is basically your Docker Compose. Very, very simple, right? Nothing difficult. So let me just mark this as well, since we have seen this. After that, the last point is basically Docker networking. All right, so now let's move to the last part, which is Docker networking, right? Docker networking is again simple stuff. So let's try to understand it. Now let's say you have one container where your Spring Boot app is running. And let's say you have other container where let's say your MySQL is running. MySQL DB basically. So there are two different containers which are running. One is running your application, one is running your database. Now how these two containers will communicate between each other? When we try to store the data over here, how this particular guy will connect to your MySQL DB and try to store the data over here, right? So this intercommunication should happen between the containers. And in order to solve this problem, we register them into a same network. Now we register both the containers in the same network. Simple stuff, right? So the containers, if we add in the same network, they will be able to communicate between each other seamlessly. So a Docker network allows containers to communicate between each other. That is basically the job of our friend Docker network. Now let me go back to IntelliJ over here. And now here if I say Docker PS, then you will see that nothing is basically running. But whenever we deploy our application, so let's say Docker Compose up over here, up -d, then you will see what exactly is created. Here one network is created, right? So whatever we mention inside our Docker Compose file, so if I go back to our Docker Compose, so all the elements that we mention over here will go inside a same network, right? So there is this network created for us. And what we can do, we can just say Docker network ls over here, right? Which will list all the networks. And here if you see, our network is basically created by this particular Docker Compose file. Now let's try to add MySQL inside our application. What I did, I have just added this particular MySQL dependency over here. This particular MySQL dependency, Spring Data JP, I have added. And what I did, I added a simple entity over here for user. So this is basically user, which contains ID, name, nothing else. After that, I have added a simple repository over here, which is JPA repository. And I have added a simple controller, which should add a user inside the database. And here in application.yaml, here I have added this particular connection, which is JDBC MySQL. And this is basically dbhost:/MySQL. And this is basically the entire connection string I have. dbhost is basically the name of our host that we will add inside our Docker Compose. And now what we can do, let's go to our Docker Compose file. Now we had app. Before that, let's try to add a MySQL database. So MySQL will be the name of our host over here. So the same name will go over here inside our application.yaml, this particular DB host, but I have added MySQL as a default one as well. So this should just work. After that, if I go back to Docker Compose YAML, then here what I will do, first what we need an image, right? So I don't really have a local MySQL image. So what I will do, I will just make use of a MySQL image from a Docker Hub. and let's give some version as well. So let's say MySQL 8 over here. After that, we'll just give a quick container name. We'll just give the same name. Let's say MySQL. We will just give restart configuration so that it will always restart. After that, let's give port binding over here. So what port we have? We have this 3306 over here. So let's just do the port mapping of 3306 at both the places. And after that, we will just attach a volume over here. This is basically the path inside our MySQL, and this is basically the name. And here what we will do, we'll just give one more volume over here, which is MySQL data. So let me just copy this from here and let me put it over here. Let's add environment as well. First, we can give MySQL root password because MySQL image needs this particular password. After that, we will give MySQL database, which will just create this particular database for us, since we are defining this database name over here. After that, we will give this DB host over here. Since here we are giving the local host API, but here we want MySQL, which is basically the name of our container or the service, right? Now what we can do, let's try to start this particular MySQL first, right? So let's see what is happening over here. So the container is basically, let's see if it is started. So it seems that it is started. Now what we can do, let's try to connect to container from our local first, right? So what I will do, I will just start this particular application on my MacBook, right? You will see that the application is basically started and it is connected to our this particular MySQL Docker. So now what we are doing over here, we are not connecting to containers, but we are running our application in our MacBook, and this particular application we are connecting to this particular container, which is just fine, right? It will just work because of our port mapping. So here we have given our port mapping right in the Docker Compose file. Because of this port mapping, things are just working fine. Our local application is trying to connect to 3306 and it is able to connect to 3306 inside our MySQL DB. Just like this particular communication, right? Simple stuff. But when we deploy our Spring Boot application in a container, let's see what happens. What I will do first, let me just stop the local application over here. I will just stop this particular application. And what I will do, I will build this application again, so that, let me just install it so that it will just build our application so that this particular jar is created, right? Once we have the jar, what we will do, we will go back to our terminal and try to create a new image. So what we will do, we'll just say docker build -t and we will give the name as, let's say, docker -demo, let's say version 3.0, right? And let's try to build it. And we did not give the path, so let's try to build it. It should build the image for us. And now this particular image, we will just replace it over here inside our Docker Compose YAML file. And let's try to bring up this particular application saying Docker Compose up -d, right? So if you see over here, container, this particular container is basically created for us, which is basically container MySQL, and container Docker demo app is basically created for us. Now if I go to services over here, then you will see that the app deployment failed. Says that could not obtain connection to query JDBC. That means it is not able to connect to our friend MySQL. And this is basically the reason, because we are giving the configuration at the wrong place. This configuration should go inside this particular app, not this particular MySQL, because this particular configuration belongs to this application.properties, where we say DB host as MySQL, which is the name of our container. Now what I will do, I will just say Docker Compose down first, and after that what we will do, make it up again. So let's see what happens this time. So now if you see, our application is basically running. I did not give -d because we wanted to see what exactly is happening on the console itself. Now if you see, our application is running and it is basically communicating with our friend MySQL database. Now let's try to perform some testing, right? So what we will do, we'll just say /users. What it is, we have post mapping /users. So let's say /users, and let's see get mappings if we are getting any data. We are not getting any data. That means things are working. and let's go to body. Here we will say name, and we will just give Chetan over here, which is basically the user. That is basically the definition of our entity from what I remember. So name we want to give, and let's make it a post API and let's send it. So it says 200 okay, and it returned empty result because we don't really have getters and setters over here. I forgot to add it. What we need over here, we need to add getters and setters. So I will just say generate getters and setters, and I'll say okay over here. Let me generate getter and setter for name as well. So now I have added getters and setters over here. So before rebuilding image, what we need to do, we need to create our jar file again. So I will just say maven install. After that, we'll go back to terminal and we need to create image again. So what we'll do, we'll create a new image, let's say 4.0 now, and let it create new image. Once that is done, what we will do, we'll go back to our Docker Compose file and update a new image over here, let's say 4.0, right? And let's try to start the services now. Let's see what happens. So now it is basically started, and if I go back and let's try to send this now, let's see what happens. Now it is still not reflecting, and the reason is because of this volumes, right? What I will do, I will just stop the container. So what I will say, I will just say Docker Compose down first. Even after rebuilding image also, it is not reflecting. The reason is because we have given this app directory as volumes, and what we need to do, we need to clean or remove this particular volume first. So what I will do, I will just say Docker volume ls, so it will list the volumes, and this particular names volume first, what we'll do, we'll just go ahead and delete. What I will do, I will just say Docker volume rm and give this particular volume over here. And now what we'll do, we'll just try to bring up our Docker application again, and now let's try to add this. And now if I try to add this, let's say post and let's try to add, then you will see it will just be added. And if we do get now, then we'll see we have a lot of stale data over here, but here we have added Chetan, right? So now our data is basically reflecting just fine. Now what exactly is happening? Your Spring Boot and MySQL both are running inside container. So if we see over here, go to services and this particular Docker Compose, then you will see that this particular application and this particular MySQL, there are two containers, but they are running in the same network. So this is basically Docker demo app underscore default, which is basically your network now, right? Within this network, we have these two containers and they are able to connect and they are able to communicate seamlessly. If you see over here, all the Hibernate queries are working just fine, because it will be able to communicate and resolve this particular IP of the other container by using this particular name that we have given over here, this particular DB name, right? So it will just resolve the IP by using container name, and it will be able to connect to that particular respective container. That is basically the concept of your networks. What you can also do, you can just say Docker network ls, which will just list all the networks for you. And this is basically the network that we are talking about here, which is basically network for your Spring Boot and MySQL, and all the services that we have inside a single Docker Compose file. For example, there are these two services will go within or will go under same network, right? So we don't really have to explicitly register or create network. This guy will create it for us. So that is basically your network. So we have seen that as well. Now what I will do, I will just push this particular repository on GitHub. And once you clone it, you don't really have to do anything. What you need to do, you just need to run two simple commands. First, you need to create image, and second, you need to just say Docker Compose up. How you will create image? You will create by using this particular command. What I will do, I will just go ahead and remove this particular version from here so that you can just give Docker demo as a name. So first command is basically simple stuff, docker build -t, you will give this name and you will give dot, which is basically the location of your Docker file, and this will just create the image for you. Now once the image is created, what you will do, you will just say Docker Compose up -d, and once you do that, you will be able to access this particular application without doing anything, right? Provided you have Docker desktop present, because this particular image you just built and this particular image will come from Docker Hub. I can just go ahead and upload this particular image on Docker Hub as well, but there is no use. You can just go ahead and look into the code as well while you learn Docker, right? So now if you see, things are basically created, and now if I try to run this code, you will see that it is just running fine. That means by using these two commands, you will be able to make it up and running with no dependency issues and no other issues as well. So that is basically the power of your Docker. Now go ahead, clone this repository and try executing these two commands and see if you are facing any issues. And let me know in the comment section how it goes for you. So we have seen many things over here. We have seen the problem. We have seen what exactly is Docker. We have seen the architecture. We have seen the installation. We have seen how we can containerize Spring Boot application. We have seen Docker files, port mappings. We have seen environment configs. After that, we have seen Docker Compose. We have seen Docker volumes and Docker networkings, right? So that is all you need to know in order to go ahead and work inside Docker, inside a real life applications, right? Simple stuff over here. So that's basically it for this particular video. I hope you have clear understanding of what exactly is Docker by now. If you like the video, hit the like button. Don't forget to subscribe to Code Snippet. Share this video with your friends so that they also have idea about Docker. That's it for this video. See you in the next video.